This is the first video on section 3.2 lines. I'm going to start with an example that's not in your notes. So this is just a typical find the equation of a line in R2 example, and I'm going to show you an alternative approach to this. So when we get into lines in 3 space, the equations will make a little bit more sense to you. So let's give the equation of the line in R2 that passes through the points 1, 2, 4, negative 7. So by now I'm guessing that this is a very easy problem for you because this is a Calculus 3 class. So what do? We find the slope of the line. So we take the difference of the y coordinates, divide by the difference of the x coordinates, and our slope is negative 3. What do we need for the equation of a line in 2 space? We need a point and a slope. We have a slope. Pick whichever point you want to work with. I chose 1, 2. Y minus the y coordinate is equal to the slope multiplied by x minus the x coordinate. And if we want to, we can simplify this and put this in slope-intercept form. And so we have our point 1, 2. We have our point 4, negative 7. We have the line that passes through those 2 points. And this is a very standard problem. But I want to show you a different approach to this. So in 3 space, what we need is a point and the direction of the line. What we used in 2 space was a point and the slope. But the slope is actually the direction given as a number. What do I mean by that? Well, here's our alternative approach. Let's set the vector w to be the vector 3, negative 9. Where did that come from? Well, that's the vector that has 1, 2 as its initial point and 4, negative 7 as its terminal point. So we start with the point 1, 2. We move in the direction length of the vector 3, negative 9, and we land at the point 4, negative 7. So this is a vector with this as its initial point, 4, negative 7 is its terminal point. Now, what I did here is I factored out the 3 to write this as 3 times the vector 1, negative 3, and then I'm going to set v to be the vector 1, negative 3, which is this 1/3 w. Why? Because v and w are parallel, and v is a little bit nicer to work with. Look at this though. If you take the second component of this vector, divide by the first component, you have the slope of the line. Same thing with this vector. So this vector gives you the direction of the line. The slope, the negative 3, is just this vector presented as a number. You could think of it that way. So, remember parametric equations from Calc 2. We can parameterize the line. X is 1 plus t, y is 2 minus 3t. T is our parameter. When t is 0, what do we have? We have the point 1, 2. It's a point on the line. When t is 3, what do we have? We have the point 4, negative 7. So this corresponds, this 1, 2 corresponds to the point where t is 0. The 4, negative 7 corresponds to the point where t is 3. This is a parametric equation of the line. You may have actually even done something very similar in Calc 2. But we can write the line as a vector equation. So here we're looking at vectors, and we're looking at the components of the vectors as a coordinate of the point. So we let r, this is a vector r, be the vector 1, 2 plus the vector 1, 3 with scalar multiple t. And so what happens when t is 0? We have the vector 1, 2, which corresponds to the point 1, 2. When t is equal to 3, we have the vector 4, negative 7, which corresponds to the point 4, negative 7. So we can write an equation in 2 space in different ways. We have our standard way that we learned probably when we first started learning about lines. We have parametric equations, and we have the vector equation. In 3-space, we're going to have parametric equations, a vector equation, and the symmetric equations. And so we'll do those in the next videos.